In supply chain management, there is a core operational axiom. The most perfect, efficient warehouse is one that does not exist. Every physical product sitting idle on a shelf represents dead capital. Across global industries, stored inventory consumes an average of 30% of a company's total assets. Yet, facilities are built anyway. They serve as a mandatory physical buffer, absorbing the shock between supply and demand to guarantee customer delivery rates and prevent manufacturing lines from stalling out. Modern warehouse design functions as a calculated solution to a highly expensive, strictly necessary physical paradox. Every storage facility is governed by a strict spatial tension between two competing metrics: volumetric utilization and accessibility. Volumetric utilization measures how densely merchandise can be packed into the three-dimensional cubic space of a building, rather than just spreading it across the floor. Accessibility measures the exact opposite. It tracks the ability for a worker to retrieve one specific item instantly, without shifting surrounding materials. This diagram illustrates the problem. As you pack goods tighter, both horizontally and vertically, to maximize volume, the items in the center are immediately buried and cut off from retrieval. Every piece of specialized hardware on the logistics floor, from heavy-duty racking systems to specialized forklifts, exists solely to artificially balance this specific scale. The most intuitive way to organize a space is fixed storage, where every single product has a permanent pre-assigned spot on the shelf. When a specific item's inventory drops, its dedicated shelf space sits entirely empty. Other products cannot be placed there, resulting in massive volumes of wasted air inside the building. The industrial solution to this waste is highly counterintuitive. It is called mobile or random storage. Under random storage, incoming pallets lack a dedicated home. They are driven down the aisle and placed into the very first empty slot available. This method pushes volumetric utilization to its absolute limit, allowing facilities to achieve up to a 90% total space occupancy. If human operators are forced to rely on their own memory to retrieve these randomly placed goods, the system instantly devolves into unmanageable chaos. Achieving maximum physical density requires the facility to strip routing decisions away from the human workers entirely, replacing them with a layer of perfect digital control. To map a randomly stored layout, facilities deploy a warehouse management system, or WMS. This software tracks every single stock-keeping unit across the grid, using strict sorting algorithms to instantly locate items no matter where they were placed. The software dictates every physical movement, starting with reception. Incoming goods are immediately counted and digitally registered at the dock to ensure strict quality control. Next comes storage. The system calculates the physical dimensions of the incoming load and assigns the most mathematically optimal empty rack for the forklift driver to use. Finally, the software orchestrates order preparation, the precise picking of items from the racks, and routes them to the exact dock for shipping. A modern logistics hub moves at high speeds because the software, not the worker, makes every routing decision. Not all inventory demands equal treatment. The software prioritizes the physical placement of goods based on their specific velocity. This is mapped using ABC classification. Rooted in the Pareto principle, this sorting dictates that roughly 20% of the products inside the building generate 80% of the total value or movement. The floor plan illustrates the strategy. Class A items, the high-velocity 20%, are clustered in red near shipping docks to minimize travel. Remaining items generate fewer requests. Class B and C goods are pushed outward into deeper corners, prioritizing dense volumetric utilization over fast access. This exact same dataset also dictates the auditing schedule. Facilities skip massive annual shutdowns in favor of continuous cycle counting throughout the year. Highly active Class A items might be counted every single month to ensure absolute accuracy, while the deeply buried Class C items are audited only once or twice a year. Mathematical probability dictates the physical geography of the shelving and the daily routines of the personnel navigating it. The single most labor-intensive bottleneck in the entire warehouse cycle is the physical preparation of orders. The most basic approach is order picking. A worker is handed a single client's request and walks the entire floor plan to manually gather each item. One worker following a single list generates tangled paths and time delays. The solution is zone picking. Workers are restricted to specific aisles, moving in optimized loops. They gather multiple order fractions simultaneously, routing them down a central line for consolidation at the shipping dock. Restricting human movement and dividing labor spatially is faster than trying to move quickly through a chaotic space. With the floor plan zoned and the labor divided, supply chain directors rely on hard data to prove their optimizations are actually working. The ultimate metric of capital efficiency is the inventory turnover rate. This data readout tracks one item over a month. We begin with a starting stock of 6. 30 units are purchased, leaving an ending stock of 4. Total sales volume, 6 plus 30 minus 4 equals 32. Next, average stock balances out to 5 units. Dividing 32 sales by the average stock of 5 delivers the turnover rate, 6.4. This multiplier is then converted into a concrete timeline, measuring exactly how long an item sits idle. Dividing a standard 360-day accounting year by the 6.4 turnover rate reveals this product sits untouched on a shelf for 56 days. 56 days of dead capital. Every routing algorithm, every barcode scan, and spatial optimization deployed exists to compress that number. If the goal is compression, the final engineering step is to force that dwell time all the way down to 0. This layout abandons volumetric storage entirely. It is known as cross-docking. Goods arrive from suppliers and flow straight across the floor to outbound delivery trucks. The merchandise ships to the client within hours. It never touches a static shelf, completely erasing the cost of storage. Executing this requires a highly collaborative business framework known as vendor-managed inventory. The client grants their supplier direct, real-time access to their internal stock levels. The supplier uses this data to perfectly time their deliveries, eliminating the client's need to hold a physical safety buffer. In its most optimized form, the warehouse functions as a high-speed data processor, where physical inventory exists as a temporary output of precise mathematics.